Chapter 6, Section 2, problem number 13. Suppose the mean number of days to germination of a variety of seed is 22 with standard deviation of 2.3 days. Find the probability that the mean germination time of a sample of 160 seeds will be within 0.5 day of the population mean. Okay, so we have information about the germination time for this particular variety of seed. So for that, we've got the mean is 22, and the standard deviation of that population is 2.3, and those are both in days. Find the probability that the mean germination time of a sample. So we have a sample of 160 seeds. We want to see if that's plus or minus 0.5 day of the population mean. Well, so the mean, because we're looking at the sampling distribution here is what our question is about, because it's looking at the sample. So the mean is the same as the mean of the distribution of the population, and the sample, or the standard deviation of that sample mean, is going to be the population of the standard deviation of the population divided by the square root of the number of points in our sample, our 160 seeds. So this is going to equal our 2.3 divided by the square root of 160, which is going to be 0.1818. All right, so now we want to go back to our population of, so we're going to be within 0.5 days, so of our sample mean, so that's going to be a half a day less or a half a day more. So we're looking here. Now we're going to transform this to our standard normal, which is our normal practice here. So 21.5, we're going to subtract off the mean, divide that by our standard deviation. We're working with our sampling distribution here. It's going to be less than or equal to a z parameter now. So 22.5 minus 22 divided by 0.1818. This is going to be the probability of minus 1.90, less than or equal to z, less than or equal to 1.90, which is going to be the probability that z is less than or equal to 1.90, and subtracting off the probability that z is less than or equal to minus 1.90. And we go into the standard normal table. I'll look inside the table to figure out what, actually the other way around. This is our z value here, right? So we're going to find the probability from that. So on our outside of the table, 1.9 gives us a probability out of the inside of the table of 9713. I forgot the 1 in there. Minus 0.0287, which gives us, you know what I just did? That's not the right numbers right there. Look at that. Everything from here down, I grabbed the wrong numbers from a different problem that was being done. So same idea, but let's get you the right numbers here. So probability of, when I subtract this out, this is minus 2.75. So I have 0.5, essentially 0.5 divided by minus 0.5 and plus 0.5 divided by 0.1818. That's going to be 2.75. It's less than or equal to z is less than or equal to 2.75. So I got our probability that z is less than or equal to 2.75. I'm going to put that line through the z to make sure it looks different than a 2. Minus the probability that z is less than or equal to minus 2.75. Period right there. And what we have here is 0.9970 minus 0.003 or 0.994. There we go. That's the probability that the mean germination time of a sample of 160 seeds will be within a half day of that population mean. So again, we're looking at sample. So within this sample, what's the probability that that sample will hit the actual population mean within a certain amount?